So welcome to this video, which is about connection setup and teardown in the transport layer. The purpose of the video is for you to understand methods for connection setup and teardown, especially focusing on TCP. So the steps in a connection, when we are talking about connection-oriented protocols, is that first we'll set up the connection, then we'll have the data transmission, and eventually we will tear down the connection. In this video, we'll focus on connection setup and teardown. Then the transmission will be covered in a later video. So when setting up the connection, usually we're working on what is called the three-way handshake. So the idea is that when the host 1 wants to set up a connection with host 2, so we can see it here in the figure A, is that first we send a connection request, then we receive an acknowledgement, and then we can start setting up then we basically send the data and we have set up the connection. So this is the usual way we're doing it. We are having sequence and acknowledgement numbers in order to ensure that this is done correctly and in order to avoid that old duplicates can play a role here. So when we send a connection request, we also send it along with a sequence number, and when we send the acknowledgement back, we do so with acknowledging the sequence number we just got and then sending a new sequence number. So we have sequence and acknowledgement numbers which are, you can say, specific to each direction. The good thing about it, and what you also see here in figure B and C, is that it's pretty stable to network errors, delays, packet loss, etc. So we can handle most situations correctly without setting up connection based on old information. And let's take a look at how it works in TCP in the next slide. So let's look at how it works when setting up a connection in TCP. Well, we're using again the three-way handshake. So first we are sending, let's assume that it's host A, which is setting up a connection to host 2. So that is what is depicted in figure A here. It is that first we send a Syn packet, then in reply we get a Syn packet, and then the last packet, which is confirming the connection. So basically we have 3 packets which are sent before we start transmitting data. So looking at the first packet, the Syn packet, what we send here is we send a packet where the Syn bit in the TCP header is set. So you might want to take a sneak peek of the TCP header and see that there is a bit which is called the Syn bit, and that is what is sent, enabled when you are sending the first packet of this TCP three-way handshake. And then we have a sequence number, and the sequence number is decided randomly depending on time in a manner that ensures that we don't have two packets with the same sequence number living at the same time. So after sending this, we acknowledge the packet, and again we have the Syn bit set, and then we have the ACK bit set as well, and we always have the ACK bit set when we are making an acknowledgement packet or a packet containing an acknowledgement. So in this case, what we see is that we are acknowledging x plus 1. So if the sequence number that we get is x, then the acknowledgement number that we send is x plus 1. Then we, in host 1, we receive this acknowledgement packet, and here we get a new sequence number, y, which is decided by host 2. So here you see that we have independent sequence numbers in each direction. And the last packet sent by host number 1 to confirm that the connection is being set up, we see that we are acknowledging based on the sequence number that we just received, and that the sequence number we are sending here is corresponding to the acknowledgement number that we got. So we can say that the sequence numbers in one direction is corresponding to the acknowledgement numbers in the opposite direction. In figure B here, you will see a situation where we are setting up 2 connections. So we are setting up 1 connection in each direction, and we see that we have the Syn bit or the Syn packet sent as the first packet. Then we have a Syn ACK packet, and then eventually, if the figure would continue, then we would also be sending the last packet of the three-way handshake. So let's look also at the connection termination. So what we call asymmetric release is simple, but it also quite abrupt and may result in data loss. So that's what we see here, that we have a connection request, we send an acknowledgement, we send the data. So that could be considered the first part of the connection. Remember though that in TCP we would actually have 3 packets before we start sending the data. Then while we are sending the data, host number 2 decides to disconnect and therefore sends a disconnect request. But that happens, we can say that this disconnect request and the data packet is crossing each other. So host number 2 is closing down everything before it receives the data. So host number 1 has no way of telling that this data did not receive host number 2, except that it will not receive an acknowledgement. So instead of this abrupt asymmetric release, where one part just decides to cut off the connection, we can also look at what is a symmetric release. So since messages can get lost, it's really tricky to ensure that both parties agree on the closure. This is what is known as a two-army problem, and that is what I've tried to draw also below. So assume that we have 2 armies representing country A. The problem is that this army is split in 2 parts, which I have called A1 and A2. If they attack B at the same time, so simultaneously, then they will win because they are bigger. But if only one of them attack, then they will not win because each of them is not in itself strong enough to attack B. So they have to ensure that they will attack at the same time. So how can we ensure that this will happen? Well, we can say that to begin with, A1 will say, we are ready to attack at this point in time, and send the message to A2. Some soldier will run over to A2 with the message. Then in order for A1 to know that the attack will take place, it has to receive a confirmation from A2. So A2 will send a soldier back to confirm to A1 that actually the attack is taking place. But then we have the problem that how do either part know that the acknowledgement is actually received? And this is what is known as the two-army problem. In practice, the way we handle this is that we want to make sure that the connection is stopped at some point in time. So if we keep on connecting and saying that we are about to release the connection, and if no communication is taking place over a number of attempts, then we'll let the connection time out. So that was the end of the video. Please, if you have any questions or comments, please let me know about it. Thanks a lot for listening.